Welcome to another Learning Together session sponsored by the Brosis Foundation. That's the Russie's Brother Sister Foundation. Our goal, our aim is to provide additional English and math tutorials for those who may find it difficult to survive during this pandemic. We hope that you will take the time and access those resources that we have created. Just yesterday I was checking, and there are now 22 videos in math on different topics. So there's a lot to choose from already, and there's still many more to come. Today, our emphasis is going to be on solving and graphing inequalities. As I've said in the past, sometimes the work gets a little bit challenging, and sometimes I pull back and do some things that are not as complex. Today is one of those days when it's not going to be as complex as it has been in some other days. So what are inequalities? Well, in order to understand and appreciate inequalities, you have to know that there are this is what we call an equation, something equal, equation meaning equal. But in inequality, instead of having the equal sign, you're going to replace it with one of four different signs. It could be this one, or it could be that one, or it could be this one, or it could be that one. Four different signs. So this says equal to, and these are inequalities, okay? This one means less than. That means strictly less than. It's not equal to, it's below, it's less than. This one, opposite direction, means greater than. So far, so good? Now, look at this. This is the first one that is modified. Instead of just having the less than sign, it has a line underneath it. And this means less than or equal to. So, for example, if I say that x is less than or equal to 4, it now means that 4 is a possibility. Whereas if I say that x is less than 4, then 4 is not an option. Okay? Good. And of course, I'm sure you could figure this one out, that this is the same as this, except with an additional. So this is greater than or equal to. It's very important to know how to, first of all, to recognize the different symbols and know what they stand for, and then how to solve inequalities. We'll discuss inequalities that involve one variable, and then we'll also look at inequalities that involve two variables, and you can see how they differ. Keep in mind that in most cases, when you solve inequalities, you treat them almost the same as how you treat equations, except that with inequalities, you end up with a range of solutions. And in some other cases, you may end up with an area of solutions. So that's something to keep in mind. With inequalities, you don't end up with one answer, you end up with a multitude of answers, okay? And again, we will develop that as we go along. So let's look at some examples of what it is to have an inequality in just one variable. Very important that we know these signs. They are different. Less than, greater than, less than or equal to, greater than or equal to. For example, solve 2x minus 3 less than 5. 2x minus 3 less than 5. For most part of your processing, you will treat it just like you would treat an equation. The process is the same, except in 2 situations only. Everything goes as normal, except for 2 situations. I will discuss those 2 situations shortly. So, if this was an equation, your goal is to get x by itself. You want x to be isolated so that you have x on one side and everything else on the other. So we need to get rid of the -3 and we need to get rid of the +2. Okay, how do we get rid of the -3? We add 3 to both sides. And that gives us 2x is less than 8. So far, nothing fancy, just the way you'd have dealt with an equation. Now we need to get rid of the 2 so I can find out what 1x is about, what we can find the value for just 1x. How do we get rid of the 2? It's a +2. And because it's a +2, you treat it just like an equation. You divide by 2. Divide by 2. And now we end up with x is less than 4. What does this mean? It means that x can be any number that is below 4. So it could be 3.5, it could be 3, it could be 2, 1, 0, it could be 2.5, it could be 2 3/4. Anything that is smaller than 4. It could even be 3.99999. That would be fine, because this is still less than 4. So any number that is below 4 would be included in this solution. There is a way to represent this so that you can get an image or get a picture graphically as to what this looks like. It is done using what is called the number line. The number line, where this is positive numbers going to the right, and this is negative numbers going to the left. So this is 0, and this is 4. So your concern, your boundary, your point of, you can't go beyond that point, is the number 4. That's your limit. So because it's less than 4, 4 is not included. So therefore, what you do is you use an open circle to represent your starting point, your limit, your boundary. And it says less than 4, which means that is every number below 4. So now you draw a line above the number line with an arrow. And that is how you would represent the solution, x less than 4, on a number line. Here is 4, open circle. Notice it's an open circle. If it was less than or equal to, where the equal to means that 4 was a solution, then it would be a closed circle. In other words, it will not be an open circle, it will be something like this. That's what a closed circle looks like. So open circle, closed circle. Okay? Good. Let's try another one. As a matter of fact, let's test to see if our answers work. We are saying that all numbers below 4 would work for this. all numbers below 4. So let me write the solution here. X is less than 4. So let's see if it's true. Let's give me a number below 4. Let's go with 2. Let's use 2, the number 2. Well, 2 times 2 minus 3, is that less than 5? Let's find out. 2 times 2 is 4 minus 3. Is that less than 5? Let's see. 4 minus 3 is 1. Is less than 5? Yes, it is. 1 is less than 5, so that's true. Let's try another number. Use 0. So we see 2 times 0 minus 3. Is it less than 5? 2 times 0 is 0. Is negative 3 less than 5? And the answer is yes. Negative 3 is below 5. It's to the left of 5. So that's correct. It works. Okay? Let's try a negative number. Let's take a negative number. Let's try. Two times negative 10 minus 3. Is that less than 5? Well, let's see. 2 times negative 10, negative 20. Minus 3. Is that less than 5? Negative 20 minus 3 is negative 23. And that, of course, is to the left of 5. It is below 5. So, yes, it works. Okay? So let's try a number. Let's try, we say x has to be less than 4. Let's try 4 and see what happens. Two times 4 minus 3, is that less than 5? 2 times 4 is 8 minus 3, is that less than 5? 8 take away 3 is 5. Is 5 less than 5? No. No, 5 is not less than 5. 5 is equal to. It's not less than. So we realize that 4 does not work. And that's why we said x must be less than 4. If we try a number bigger than 4, this is going to give us a larger number, minus 3. So the answer is going to be bigger than 5. Let's test it. Give me a number greater than 4. Let's use 5. So 2 times 5 minus 3, is that less than 5? 2 times 5 is 10 minus 3, is that less than 5? 10 minus 3 is 7, less than 5, and that's no. So we realize that 5 would not work. And any number you use above 5 is going to give you an answer bigger than 7, because 2 times 20 is 40, take away 3 is 37. So whatever number you use bigger than 4 is going to end up with a number that is bigger than 5. Okay? So that's what we just did, was we checked to see if our answer made sense. And nothing is wrong with doing that every now and again until you're confident in the procedure. So let's go on to another example. Now, we will not be checking all of them, but I just wanted to give you an idea of how you could check your answer. So already you can tell that today is a lighter day than some of the other days, right? Let's try number 2. 6x minus 5 minus 8 is greater than or equal to 3x plus 10. Okay, let's go. So our goal is to get x by itself. Couple things happening here. I see x here and I see x here. I see a constant here, I see a constant there. So maybe we need to try and get all the x's on the left and all the constants on the right. So how do I get rid of this negative 8? Add 8 to both sides. So now we end up with 6x is greater than or equal to 3x plus 18. Now we need to get these 3x's over to this side. So we subtract 3x's. Again, nothing dramatic. Just the same procedure would have used if this was an equation. Same procedure. So now we end up with 6x take away 3x is 3x. And this is 0, so we're left with 18. Now we have 3x is greater than or equal to 18. We need to get rid of the 3, and it's a positive 3. So guess what? We divide both sides by 3, and it's just business as usual, nothing strange. And what do we end up with? Divide by 3, we end up with x is greater than or equal to 6. What does this tell you? It says that x, any value of x that is greater than or equal to 6 would work perfectly in that inequality. It would perfectly work, okay? So how do you graph that solution? Well, 6 is the magic number to focus on. So if you draw your number line, this is your 0, this is your 6. It is greater than or equal to, which means that 6 is included in your solution set. So what you do here, you do a closed circle, not open, a closed circle, and it's greater than, so it's above. So that means it will be all the values going in that direction. All numbers going in that direction. In some situations, they will draw your solution set on the number line. I tend to do it above the number line so you can see visually, without any shadow of doubt, that your solutions will be from here, everything to eternity would be included. Okay? So let me write the solution here. We're saying that x greater than or equal to 6 would work. So what we could do now is we could check to see if that's true. So x has to be greater than or equal to 6. So let's try a number below 6 and see what happens. Let's try 5. So it moves. 5 is less than 6, so this should fail. It should not work if we are correct. Let's go. 6 times 5 minus 8. Is that greater than or equal to 3 times 5 plus 10? 6 times 5 is 30 minus 8. Is that greater than or equal to 15 plus 10? 30 minus 8 is 22. Is that greater than or equal to 25? The answer is no. And we were correct. X must be a number that is bigger than or equal to 6. When you use 5, it does not work. Let's try 6 and see what happens. So let's use 6. Six times 6 minus 8. Is that greater than or equal to 3 times 6 plus 10? 6 times 6 is 36 minus 8. Is that greater than or equal to 18 plus 10? 36 minus 8 is 28. Is that greater than or equal to 18 plus 10 is 28? Oh, that is true. 28 is equal to 28. So this is fine. That's perfect. So we realize that 6 is as part of the solution set for that inequality. Notice I said solution set because it's an infinite number of possible solutions. Okay? Let's try 2 more and then we move on to another example. Let's try a number bigger than 6. So use 12. And let's see what happens. What is our expectation? It says x must be greater than or equal to 6. We're using 12, so therefore we expect that 12 should work in this situation. Okay, so 6 times 12 minus 8, is that greater than or equal to 3 times 12 plus 10? Let's see. Okay, 6 12, 72 minus 8. Is that greater than or equal to 36 plus 10? 72 minus 8 looks like it's 64. Is that greater than or equal to 46? The answer is yes, it is. So it works. So now I'm going to try one last one. I'm going to use a number that is negative. We didn't use any negative numbers. Let's try a number that's negative and see what happens. So use negative 4. Let's try negative 4. Now, x must be greater than or equal to 6. We're using negative 4, which is less than 6. So this should fail if we are correct. Let's go. Six times negative 4 minus 8, is that greater than or equal to 3 times negative 4 plus 10? That is the question. 6 times negative 4 is negative 24 minus 8. Is that greater than or equal to negative 12 plus 10? Negative 24 minus 8 is negative 32. Is that greater than or equal to negative 2? Negative 32 is further to the left. Out of owing $32 and owing $2, which one is a better situation? This is a better situation. You have more value here than here. Here you're more in debt. So this is a greater negative. If you can understand that, it's more negative. Okay, so this is a lower number. So this is not true. It fails. Negative 32 is not greater than negative 2. Okay, another way to explain it is, this is a number line. This is 0. This is negative 2. This is negative 32. The further you are from 0, the lower your value is. So as you go to the left, you are getting less value. As you get closer and closer to 0, from the left is greater value. And as you move further and further to the right, the value keeps going up, 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 up. Okay? So that takes care of that. So far, everything that we have done, we would do just the same as if it was an equation. But I keep hinting that there are 2 situations in which it would not work like an equation. We have to do something a little different. Let's do one. 5x minus 12 is less than 6x plus 4. Five x minus 12 is less than 6x plus 4. So we need to solve and see what values of x would satisfy that inequality. As always, you want to get x on the left and your constants on the right. So let's get rid of this negative 12 by adding 12. We end up with 5x less than 6x plus 16. So now we need to get rid of this positive 6x. So I need to bring it over here. So how do we do that? We subtract 6x. When you subtract 6x from here, you end up with negative x less than 16. But we do not want to find what negative x is. We want to find what positive x, what range of values would satisfy positive x. So we need to get rid of this negative sign. Well, if we multiply the left-hand side by a negative number, this becomes positive. We also have to multiply the right-hand side by the negative number. Okay? But here's what happened. Whenever you multiply both sides of an inequality by a negative number, the inequality flips. So instead of less than, it becomes greater than. So when you multiply by -1, this becomes greater than. It does the opposite. And then you have -1 times 16. So now the answer is x is greater than -16. So that is your final answer, x greater than -16. So we need to prove now we are in a situation where we changed up our inequality. We started off with less than, ended up with greater than. So now I know you want to find out, is that for real? Is that correct? Or did we make a mistake? Well, first of all, let's graph our solution. Our solution is going to be something like this. It says x is greater than -16. So -16 is our bottom line, and this is 0. So it is strictly greater than. So I need to go open circle because it's a greater, strictly greater. So -16 is not included. And since it's greater, we're going to the right because that's what greater means. So that's going to go all the way to infinity, continuously, forever, all the way to the right. So x is any number that is greater than -16. So now I need to prove that that is correct. So what that means is that if I use -16, it will fail. If I use any number on this side of my graph, it should fail. But any number above -16 should succeed. Okay, let's go check it out. Let's use -16 to start. Again, our answer was x is greater than -16. That's our answer. So we're going to use -16. So -16 should fail because x is supposed to be greater. So if I use -16, it should not work. We go 5 times -16 minus 12. Is that less than 6 times -15? Not 50, -16. Plus 4. That is the question. So 5 times -16 is -80 minus 12. Is that less than 6 times that is 96 plus 4. Negative 80 minus 12 is negative 92. Is that less than negative 96 plus 4 is negative 92. So is negative 92 less than negative 92? No, it's not. It's equal to. Not less than, but it's equal to. So therefore, this does not work. That is not true. It's not less than negative 92. Okay? Let's try a number down here like negative 20. Let's try negative 20. No, negative 20 should fail because it's to the left of negative 16. So anything to the left should fail. Let's find out. Go. 5 times negative 20 minus 12. Is that less than 6 times negative 20 plus 4? 5 times negative 20 is negative 100. Is that less than negative 120 plus 4? This is negative 112. Is that less than negative 116? Negative 112 is closer to 0. So this is not less than negative 116. As a matter of fact, it's greater than. So therefore, this is not true. So we prove that if you have a number that's below negative 16, that it fails. Okay? Let's try a number that is above negative 16. So let's try negative 10. So we're going to try something that is here and something that is over here. So negative 10. So 5 times negative 10 minus 12. Now negative 10 is here, so we expect it to succeed. We expect it to work because it's in the range from negative above, it's in the range above negative 16. So is that less than 6 times negative 10 plus 4? That is the question. So this is negative 50 minus 12. Is that less than negative 60 plus 4? Negative 62. Is that less than negative 56? Is negative 62 less than negative 56? If you owe $62 as compared to owing 56, which one is a better position? That's a better position to be in. So this is true. Okay, negative 62 is less than negative 56. Okay, negative 56 is a bigger number. Okay, finally, let's use positive 10. Again, just like negative 10, positive 10 should work also. So positive 10, we end up with 5 times 10 minus 12. Is that less than 6 times 10 plus 4? That is a question. 5 times 10 is 50 minus 12. Is that less than 60 plus 4? 50 minus 12 is 38. Is that less than 64? And the answer is yes. So we have proven that what we did where we end up changing the inequality was actually correct. Okay? So let's do one more example, and then we're going to go into inequalities involving two variables. Okay, 20, this is number 4. 20 minus 5x is greater than or equal to, let's go with let's go with 35. So we need to get x alone on the left, so we need to get rid of the 20. So we subtract 20, subtract 20. So now we end up with 0. So this is negative 5x. I don't need to write the 0. It's not necessary. Negative 5x is left. Is greater than or equal to 15. So now we need to get x by itself. We need to get rid of the negative 5. In the previous example, we discovered that if you multiply both sides by negative 1, it changed the inequality. Guess what? If you divide by negative 5, by a negative quantity, it will also change. So if you multiply both sides by a negative number, it changes the inequality, it flips it. If you divide by a negative number, it flips it. Either way, as long as you're using a negative number to multiply both sides or to divide both sides, the inequality will change to the opposite. So when you divide by negative 5, I always recommend that you skip this line and come to this to show your division. So you can show that you're dividing by negative 5. So now you need to flip the inequality from greater than or equal to less than or equal to. So that's the opposite of this. And then you're going to have 15 divided by negative 5. So what's the final answer? This divided by that, you end up with x less than or equal to negative 3. X less than or equal to negative 3, the graph looks something like this. This is a 0, this is a negative 3, and it's less than or equal to, so it's a closed dot. Okay, and of course, closed circle, and you're going less than, so you're going to the left. And then so there was x less than or equal to negative 3. And what we need to do now is to test to see if it works. So we're going to do 3 tests this time. We're going to try negative 3, see if that works. Try a number below negative 3, and try a number above negative 3, and see what happens. Uh-oh. I just erased the inequality. What was it? 20 minus 5x is greater than or equal to 35. I think that's what it was. So minus 5x is greater than or equal to 15, and then x is less than or equal to negative 3. Yes. So let's use, okay, a number that is less than, well, let's use negative 3. Use negative 3. So 20 minus 5 times negative 3. By the way, negative 3, it says equal to, so it should work. This should work. Okay. So 20 minus 5 times negative 3, is that greater than or equal to 35? 20, negative 5 times negative 3 is 15. Is that greater than or equal to 35? 20 plus 15 is 35. Is that greater than or equal to 35? Yes. It is actually equal to 35. So the or means that it can be greater than or it can be equal to. So it satisfies the equal to, so it's good. Okay. Let's try a number that's less than negative 3, and that should work. If I try negative 10, let's try negative 10 and see what happens. This should work. Negative 10 is less than negative 3, so it should definitely work. Here we go. 20 minus 5 times negative 10. Is that greater than or equal to 35? That is the question. So 20 minus 5 times minus 10 is plus 50. Is that greater than or equal to 35? 20 plus 50 is 70. Is that greater than or equal to 35? The answer is yes. It is greater than 35. So that works. So we said any number below negative 3 should work. Let's try a number above negative 3. And then that should take care of this for us. So what number we're going to use? Let's use 20. So 20 minus 5 times 20. Is that greater than or equal to 35? Well, let's see. If we use a number that is above negative 3, it should fail. It should not work. It's not in the solution set. It should fail. So let's see what happens here. 20, negative 5 times 20 gives you negative 100. And 20 take away 100 is negative 80. Is that greater or equal to 35? Is negative 80 equal to 35? No. Is negative 80 greater than 35? No. So this is not true. Okay, so 20 fails. So anything that's above would not work. So yes, we're good. So now we have dealt with inequalities in one variable. Now let's go to two variables. So this is going to be number 5. Y less than 2x plus 3. So there's a variable, x and y. These are the two variables involved. And they say graph the solution to this inequality. So I'll tell you from now, to draw this graph, it's going to be, this is a linear equation. Y, if you have an equal sign, it's a linear equation. So you're going to have an equation, you're going to have a line, something like that. We'll discuss the details afterwards. And your answer is going to be either below the graph, below the line, or above the line. That's it. So it's for you to be able to, 1, draw the graph, which is something we did about 2 weeks ago. We learned how to draw the graph of a line. And then 2, decide if we're shading below the line or we're shading above the line. So those are the 2 things that we have to do. Keep in mind that when you draw the graph, when you draw the line, which is really your boundary, you're going to end up with either a solid line or a dotted line. You will use a dotted line when it is strictly less than, but if it's a less than or equal to, you'll use a solid line. So if we have this or this, we use dotted line, which is, and if we use this or this, we use, very important, solid okay. So if it is strictly less than or strictly greater than, we use dotted line. If we use less than or equal to or greater than or equal to, we use solid line. Okay? So in this case, it is strictly less than, so it's going to be a dotted line. Okay. Now, how do we draw the line? Well, what you do is you treat this like it was a line, an equation like y equal to 2x plus 3. Draw this graph. Okay, this is what you're going to use to get your points on the line. And then when you're drawing the line itself, which is your boundary, you know it's less than, so then you're going to use a dotted line. So for this, what I'm going to use is I'm going to use the y-intercept and the slope. According to this, the y-intercept is 3. So, by the way, we discussed this in a previous lesson, so we don't need to spend time doing the graphical line here. We did that before. So that's your y-intercept. And then the slope is 2. So it means that you go 1 across and you end up with 2 up. So your line passes through these 2 points. So it's going to be, and it's a dotted line, so it's going to look something. Okay, so this is it. You label your line, which is your boundary. It is y equal to 2x plus 3. So this is your boundary. And now for the inequality, you have to decide whether you're going to label above or below. Less than, if you think in terms of literally, if something is less than, it is below. So just by literally looking at the sign, you know that you should shade below the graph. So this is how you shade the graph. It's everything . So that of the graph of this inequality here is everything below because it is less than. If it was greater than, you'd have shaded above. So let's test to see if we're correct. The shaded region represents all the points that satisfies that inequality. Every point in this region satisfies that inequality. So if there's a point that is over here, then it should fail when you try that test. So for example, I say to you that the y-intercept is the point 0, 3. So I guarantee if I try a number, say for example 0, 5, that's in the clear area, so it should fail. Any number that's above this dotted line should fail. Any point should fail. Then if I choose a point that is over here, anywhere here, it should pass. So let's try a number. Let's try a point. Let's go for the point. We could use -1, or we could use the point 1, 7. 1, 7, that's somewhere up here. That's 1, 7. So use 1, 7. This should fail. And I'm going to use another point over here. It should fail. Okay, so x value is 1, y value is 7. Is 7 less than 2 times 1? Is 7 less than 2 times 1? The x value is 1 plus 3. Is 7 less than 2 plus 3? Is 7 less than 5? The answer is no. 7 is actually greater than 5. So that's not in your solution set. It's not in your shaded area. So we always shade the area that represents the solutions. Okay? Let's try another point. Let's try another point. Say -4, 6. Use -4, 6. So that's something in the second quadrant here. -4, 6. Okay, so the y value is 6. Is 6 less than 2 times -4 plus 3? Is 6 less than -8 plus 3? Is 6 less than -5? The answer is no. So this doesn't work at all. So let's choose a point that is in the shaded area and see if that works. Use, let's go for 4, -2. 4, -2. 4 plus 2 down. Definitely in our area. So the y value is -2. Is -2 less than 2 times 4 plus 3? Is -2 less than 8 plus 3? Is -2 less than 11? Yes. So you see it works. Let's try another one. Let's go for one that is over here. Let's try -1, -5. So y is -5, x is -1. So -5 is that less than 2 times -1. So this should work because I'm saying that that's in the shaded area. 2 times -1 plus 3. Is -5 less than -2 plus 3? Is -5 less than 1? The answer is yes. So you see it works. Let's try another one. This is number 6. This time we're going to go with two y greater than or equal to 6x minus 10. Oops. Oh. Let's say 10 minus 6x. The first one we did at a positive slope. This time I want to do a negative slope. So what do we see here? For the graph, you want to get y by itself. So y is greater than or equal to, I'm dividing both sides by 2. Greater than or equal to 5 minus 3x. So we're going to consider the line y equal to 5 minus 3x. So this is your y-intercept, and that is your slope. Okay, so here we go. This is your x-axis. This is your y-axis. So our slope is, our y-intercept is 5. And a slope of -3 means that I go across 1 and it comes down 3. So this is 2. Okay, so this comes down to here. This is one point, and this is another point. All you need is really 2 points on a line and connect the 2 points and extend, and that's your graph. So it is greater than or equal to, which means that you're drawing a solid line. Solid line. So how should we draw this? So here we go. Okay. Then of course, our graph, this is a graph of our boundary, which is y equal to 5 minus 3x. So that's our boundary. Our dividing, that's our border. It divides the area that is your solution from the area that is not your solution. So now where do I shade? It says the y value has to be greater than or equal to the points on the line. So the y value has to be the points above the line, including those on the line. Greater than means above. So therefore, you shade above the line. Okay, get the picture? So that's how you draw the graph of an inequality in 2 variables. And then I promise you, if we check any point below the line, it should fail. And if we check any point above the line, it should pass. Okay? So let's check. Use 0, 0. We agree that the origin is below your graph, it's below your line. So therefore, it's in the clear area, so it's not shaded, so it should fail. X is 0, y is 0. Let's go. Is 0 greater than or equal to 5 minus 3 times 0? Is 0 greater than or equal to 3 times 0 is 0, 5, and the answer is no. It does not. So it fails. So that's good, because we're saying that these points over here do not work. The points in the shaded region, we're saying, yes, they work. Let's try another one. Use. Well, I could go over here and take a point, say negative, this is 0. I could say negative 6 and negative 4. Let's try negative 6, negative 4. That should work, should not work, because it's in this area, which is clear. Let's see if that's true. So y is negative 4, x is negative 6. So negative 4, is that greater than or equal to 5 minus 3 times negative 6? Is negative 4 greater than or equal to 5 plus 18? Is negative 4 greater than or equal to 23? The answer is no. So we see that it's perfect. Let's try one more example. Let's try something that's in the shaded region. So how about, let's use the point 37. Let's use the point 37. So x is 3, y is 7. So 7 is 7 greater than or equal to 5 minus 3 times 3. Is 7 greater than or equal to 5 minus 9? Is 7 greater than or equal to negative 4? The answer is yes. So we see it's consistent. Okay? So the only thing that I would need to do is to show you what happens with the graph, the inequality that involves, say, for example, you graph 2 inequalities and find what area corresponds or satisfies both inequalities. We'll pick that up in our next session, which will be on Thursday, and then we should be able to seal inequalities from there. We'll also run a couple of examples dealing with, say, a parabola or a circle and see what happens. I do hope that this reminded you of some of the stuff that you might have already learned. And if you never learned these before, then this is now something new for you. Again, part of our objective is to provide something for all students. Some students in the advanced and some students in the beginning section. There will be something for each person. So this video, this session today makes our number 23 for mathematics. So we're making progress, and again, we're going to be doing so much more. So on behalf of the Brosis Foundation, we thank you for joining us in another session of Learning Together. We hope that you'll share this information with others so that they too can benefit from the rich resources that we're providing, both in math and in English. So both of them can be accessed to the Brosis Foundation, and hopefully you'll continue to use them. Enjoy the rest of your day. Thank you.